Conversion of hardwired to ladder logic systems. Firstly, we're going to look at the direct online starter. On the left over here we have got the typical wiring diagram, which includes an overload, an emergency stop, our normal stop button, our start, our contactor with a latching or the retaining contact. On the right hand side we've got our PLC, and these devices are all the devices that we're going to find in our wiring diagram. Now, when connecting up our PLC, we are going to, let's accept that this is a DC PLC. It runs off direct current, which means it's going to need a positive as well as a negative voltage supply connected to it. The positive supply is then going to connect onto each individual device: start, stop, emergency stop, and the overload relay. If I'm not mistaken, that one is labeled 96 and 95, those 2 points on the actual overload. Those three are just normal buttons. And then my inputs, these different switches, are all going to connect to my PLC, each in its own input from I1 to I4. On the output over here, I'm going to have my live. If this is a high voltage output, I'm going to have my live that is going to connect to, in this case, my pin 2, and then from pin 1 we're going to connect to the actual contactor on, I believe it's A1 and A2 connecting pins, and that is going to connect to neutral at the bottom. Apologies. Live through the contact, through the contactor to the neutral supply. If this is a DC, if this is a low voltage, then I will, instead of having live and neutral connecting to the contactor, I will have a relay connected in series with Q, which is then supplied off positive and negative supply voltage. So that is how we will wire the PLC according to the wiring diagram. Let's look at how to do the ladder logic. So we've got our 4 inputs. Input 1 in the simulation is a momentary make button, start button, and let's label it as start. Okay, then we've got our second input, which is my stop button, which is a break, and comment label as stop. Okay, third input, okay, is my emergency stop. In the simulation it's an actual switch. It stays closed until there's an emergency. When you press it, it'll then open. And our last input is our overload, which is on input 4. Input 4 is my overload, and I'm going to use that as a normal switch as well. These then all connect to the relay coil Q1, which according to the wiring diagram is MC1. That will connect to my contactor. I'm connecting all of them in series with each other, and now I need to add my latching contact, which is linked to Q1. Yeah, Q1, and that is in parallel with my start button. Now running the simulation, my overload and my emergency button are both closed. When I press the start button, Q activates. That activates the latching contact, which in turn keeps the entire circuit open. Pressing the start button has no effect. If I press the stop button, then it stops Q from operating. Same with the emergency stop when I reset it, and my overload when I reset it stays correct. And there is the direct online starter ladder diagram.